Hello everyone, and welcome to this TTK tutorial. My name is Charles, I work at Kitware, and together we will see an introduction to ParaView. First, I will give you an history of ParaView, and then I will show you the ParaView interface. Then we'll work together as we will import data into ParaView and use some filters for a basic exploration. At the end, I will show you how to automate stuff in ParaView using scripts, and I will add some advanced manipulation that are useful in the context of TTK. ParaView is an open source software which is maintained by Kitware and which has an BSD license, which is a really permissive one. You have here some statistics about the GitLab repository. It's an end-user application, which means that it's meant to be used without any code. In fact, it's used by a lot of researchers or scientists that try to explore a dataset that can be really large data. It's based on VTK, which is a famous library in scientific visualization, which is both modulable and extensible. ParaView has a client-server architectures, which means it's really scalable from the small laptop to the largest supercomputer in the world. Here is an example of a data exploration using ParaView. This example comes from the TTK website, and in the centers you have the results of our analysis with a 3D dataset and several charts. We will go further on these charts and these data through this TTK tutorial. On the left you have the pipeline view, which shows you the data you have loaded as well as the chain of filters you have applied on this data. And below you have a properties panel, which can be used to interact with all the properties of these filters as well as with the properties of the different views. At the top you have the main panel. It contains shortcuts for the most commonly used action. You can customize this panel as you wish. At the top left of the render view you have several buttons for commonly used action. So you can create a screenshot, you can change the way the mouse interact with the data, and you can create selection on the point or on the sale data. On the right of the view, you have some buttons that allow to interact the view window, to split it, to maximize it, or to close it. You can also change the kind of view that you want to use, to choose, for example, a spreadsheet view, a chart view, and there is a lot of other kind of view in ParaView. Here we have a dataset, and let's say we want to change the color scheme that is used to represent the scalars on this dataset. So we select the dataset we want to modify in the pipeline view. We go into the display properties in the properties panel, and there is an edit color scheme button that can be used to get this dock on the right. As this is a really commonly used action, you also have a shortcut directly on the main panel that will also bring this dock. With this dock, you are able to change the transfer function for a volumetric rendering, and also to change the preset of the color scheme, and you can do more advanced customization if you want. Let's try to do this together. For this, we need data. To open data into ParaView, we use the really common file open dialog that you can also bring with Ctrl-O, and you should have received an archive with different data prior to this tutorial. So let's use the data which are inside this archive. Here is my ParaView, so file open, and I will open molecule.vti. When you open data in ParaView and when you create filters in ParaView, there is no the data is not rendered or the filter is not applied directly. You need to specifically apply, so you can load really large data sets and create some modification, some customization of what you want to do without exploding your memory. Here, by default, we only have the outline of the dataset. If we want to change this, in the property panel, you have the representation menu, and let's say, for example, that we will choose the surface representation. The coloring may be done using the scalar fields you want. And once again, as it's a really common action, you have a shortcut directly in the main panel. So for example, we can switch here to the volume representation. If we want to edit the color scheme, we have here the edit button that brings the dock that we have seen previously. This dock can be used to change the transfer function, as you see here. You can here add a new color to create the color map you want, and you can choose among the existing color maps here. So, as we have seen, the parameters that concern the filters needs to be applied using the apply button, so you can tune them without recreating the data, and the parameters of the view are just below. Here are some examples of commonly used filters. The clip filters, which allow you to cut the dataset using a plane, using a cylinder, using a box, and there is other properties. The surface filter, which extracts the surface of the dataset, so it will be a polydata. The threshold filters, which allows you to extract all the cells between a given scalar range. And the contour filters, which allows you to compute a contour at a given or several given ISO values. Some other filters that may be useful during our exploration with TTK, the tube and the spheres, which can improve greatly the representation of a graph or trees. The clean to grids, which will merge the points which are duplicates. The tetrahedralize, that will transform your dataset into triangles and tetrahedron, which is useful for TTK. The surface normal filters, which recompute the normals after you have changed the geometry, and so it improves the light, the reflection of the light in your datasets. The Python calculator, and there is a lot of other ones. So let's try some of them together. Here I have my data, so I can open a filters using the filters menu. Here, as you can see, each filters has a category, and so if I want the clip filters, I can choose command clip filters. I can interact with the widget of the view, and when I'm happy, I apply this to my datasets. Using the pipeline browser here, I can choose what I want to display on my view. So let's say, for example, that I only want the clip. So I hide molecule.vti. Let's try another filters. So if I want a contour, I can use the control space menu, which is a search for the filters, and I type contour. Okay, so now I have my contour filters. I want to make a contour by log row at the given value and apply. And now I have my contour inside my datasets. I can hide molecule again so we see it. Now, the automation parts. Once you have created a large pipeline, you may want, of course, to save the result of this pipeline, but maybe the pipeline itself. So you can share this pipeline with people, or you can re-execute this pipeline later. This can be done using ParaView state files. There is two kinds of ParaView state files. PVSM, which are meant to be shared, as when you apply a PVSM state file, ParaView will ask you to pick up the file on which you want to apply the pipeline. So even if you have different paths than the people that give you this state file, it will work like a charm. And you have the Python's state file, which can be used, of course, in ParaView, but can also be used in PV-Pythons, which is the ParaView version of Pythons that does not bring the interface, and so this is really useful for batch processing. ParaView will also let you save screenshots of the data you have displayed on screen. So, for example, here I can save a screenshot of my contour by using File, Save Screenshots. Let's say I want my screenshot to be named test.png. Here I have some parameters I can tune, and OK. And now I have a test.png file with this image on it that will contain only the content of my main view. We can interact with ParaView using Pythons, and one way to do it is using the Python shell. So let's summon this Python shell, view Python shell. Let's close it as we do not need it anymore. Okay, and now I can type Python's command like get active view, for example. Okay, and M is now a ParaView server manager object, and I can create filters, change parameters of my filters, and so forth. The best way to learn how to do something in Pythons in ParaView and what you can do with Pythons inside ParaView is to let ParaView do it by itself, so you can learn what methods correspond to what action. For this, you can use the start trace option, the start trace tool, sorry. So let's try it. Tools, start trace. Let's say we want to show the incremental trace. Okay, and now when I do any action, I will have them saved here in a file. Okay. And here, if we have a look, we can see I have shown what is in the first layout, and I have hide what is in the second one. Stop trace. And here we have the final results. Now let's see some advanced manipulation. So we can create some advanced selection. So on the left we have seen there is some basic selection that you can create with the mouse, and here on the right we see the interface meant to create more advanced selection. Edit find data. So let's do this. Edit find data. I want to find points, for example, in the molecule.vta entry, and I want those with an ID which will be greater than 100, and that will be lower than 200, for example. Okay, and here are the corresponding IDs on my data. ParaView can also be used to create animations. So here we have a data set with a contour. Let's try to animate the contour so we can see the contour move through time. So for this we need the animation view, and we want the value which is used for the contour to vary through time. So we add this entry that will change the isosurface through time, and we want this value to change from the minimum one to the maximum one in the scalar range. Okay, and now if I press play, I will see the contour evolving through time. I need to show, of course, the contour for that. It's a bit fast here, so let's try to slow down things a bit. And here we see our animation. Then, to finish, ParaView can be extended using plugin, and TTK is one of them. So let's see how we can load a plugin into ParaView, or check that a plugin is already loaded into ParaView. For this, you have the Tools Manage Plugin window. So, Tools, Manage Plugin. And if TTK is correctly installed on your computer, you should have here an entry, Topology Toolkit, which should be loaded. If it's not loaded by default, you can use the autoload entry. Here is the end of this presentation. This work has been supported by the VIS project, and good continuation in this TTK tutorial.